a continuation of the lesson from yesterday, which was vector operations. So today is just additional vector operations. Problem number 1, it asks us to find the magnitude and direction of vector u in component form, -4, 3, and vector v also in component form, -16, -1. So on Monday, we learned the formula for magnitude. So let's start by finding the magnitude of the first vector, which is vector u. And to find the magnitude, it's the square root of the x value squared added with the square of the y value. Now, remember the component form is when the initial point is at the origin, and over here, this point represents the terminal point. And this is an ordered pair, so the first value is your x, the second value is your y. So in my formula over here, instead of x, what is the x value of the component form? So -4 needs to be squared. Add to that the y value squared, and the y value is 3. What is -4 squared? 16. What is 3 squared? 9. What is 16 plus 9? 25. So this would be equal to the square root of 25, which is equal to 5. So there's the magnitude for vector u. Now, similar process for vector v. So finding the magnitude of vector v, the magnitude will be the same formula, square root of the sum of the squares of x and y. What do I use for x? So -16, square it. Add to that, what is the y value? -1, square it. What is -16 squared? 256. What is -1 squared? So 256 plus 1 would be 257. So this would be equal to the square root of 257. Now that radical, can I simplify that radical? No, there's not a perfect square we can use for 257, but if there were, then you would have to make sure your radical is in simplest form. Now, it's really important that with these questions you answer everything that's asked. So did I answer everything that was asked? Yeah. We solved for only the magnitude. The next thing we need is the direction. Now, for this problem, when we're looking for the direction, we're really looking for theta in standard position. So standard position means the initial side is on the positive x-axis. The terminal side is wherever the vector is placed. So the first thing we need to do is go ahead and draw a diagram so it's more clear of what I just said. Okay, and as a reminder from yesterday, component form means the initial point is located where? At the origin. And whatever point I'm given in the component form, that represents the terminal point. So the terminal point, I need to plot that point. So -4, 3. -4, 3 would be right here. So here would be my vector. Now for this vector, when we're trying to find the direction, we're just looking for the angle in standard position. So standard position, my initial side is on the positive x-axis. I rotate counterclockwise, and that would represent theta, just the angle in standard position where the terminal side is the vector. Now, in order to find theta, it would be really nice if we knew this angle right here. But we could find that angle using triangle trig. If I turn this vector into a right triangle, what is this side length? -4. And what is the height? 3. I'm not going to use theta here because I'm using theta to represent the angle in standard position. So let's call that smaller angle, let's call that alpha. Kind of looks like a fish, alpha. Or it kind of looks like an A for alpha. So to find alpha, notice for alpha, we are given the opposite side, we are given the adjacent side. So if I'm given both of those values, what trig function should I use to solve for alpha? Tangent. So that means the tangent of alpha is equal to opposite over adjacent. Now that negative 3/4 is the arctan value. So make sure when you put that in the calculator, you do second tangent of negative 3/4. And we're going to have our answers today in degrees. So first, make sure your calculator is set to degree mode. And again, with the angles, we're going to round to the nearest whole degree. So make sure you're in degree mode. Second tangent of negative 3/4, and round to the nearest whole degree. And what would alpha be? 37 degrees. I agree. Yeah, it says negative 37, but really, is that a negative angle? Yeah, we're using the functional value, so it's going to be 37 degrees. Now, what we need to do next is, let's see, we're not looking for alpha, we're looking for theta. So how would I find theta? Yeah, it's a linear pair, so theta is 180 degrees minus 37 degrees. So that means theta is 143 degrees. So there's our direction. And for the direction, we're just looking for the angle in standard position. Okay, now we have to do the same thing for vector v. No, not boo. This is exciting. This is fun. You don't like graphing? Okay. For vector v, the component form is negative 16, negative 1. Now remember, component form, that means the initial point is where? At the origin at 0, 0. Now here the x value is negative 16. I'm not going to count all that way. I'm just going to estimate. I'm going to say negative 16, negative 1. I'm going to say right there is the point. So there is my vector, the resultant vector. Now if I go ahead and make my right triangle, what would I label the top piece? Negative 16. What about this leg? Negative 1. And again, what we're looking for theta, the angle in standard position. So from the positive x-axis all the way over here to where our vector is. That represents theta. So before I can find theta, I first need to find this small angle here. And instead of calling it theta, I'm going to call it alpha. So we need to find angle alpha. So looking at alpha, we know the opposite side, we know the adjacent side. So what would I use there? Tangent. So again, tangent of alpha is equal to, the opposite side is negative 1, the adjacent side is negative 16, and I can simplify that, but really I don't have to because I'm putting it in the calculator anyway. But if I do simplify, it's positive 1/16. Now again, we want our answer in degrees. We're going to round to the nearest whole degree, and that is an arctan value, so make sure you do second tangent. So second tangent of 1/16, what is alpha to the nearest whole number? 4 degrees. So if this angle is 4 degrees, how would I find the total angle for theta? Do I subtract it from 180? Add it to 180 because I went 90 degrees plus the extra 8. I subtracted from 180 because this angle is smaller than 180 degrees. So theta is equal to 180 degrees plus the additional 4 degrees, which would be 184 degrees total. Now, have we answered all the questions for problem 1? Yes, we have magnitude, we have the direction, so we're moving it on to problem number 2. Problem 2, for vector u, the magnitude is 20, and the direction is theta is 150 degrees. And for vector v, the magnitude is 25, and theta is 270 degrees. We need to convert vector u and vector v to component form. So, let me draw a diagram so we can have a talking point here. And I've already said this today, but when you talk about component form, where is your first angle? At the origin. And for component form tells you where the terminal point is. Let me just say my terminal point is here. So here's my vector. And in the problem, they're giving us the length of the vector, and they're saying it's 20. Right now, I'm just going to call it r, just for generic purposes.